Welcome back, you crazy people. In semester calculus? Okay. I'm Dr. Sassmore. This is hopefully familiar to most of you. Those of you that haven't gotten to know me yet, I look forward to getting to work with you. My office is across the street in Lynch. Most of the time you'll find me in the Enrichment Center. Reeves 108, first floor, go right up from the quad, and you'll find it all the way in the back of the building. All of my office hours will be held there. Monday, Wednesday, Friday, that's 12:30 to 1:30. Tuesday and Thursday, it's in the afternoons, 1 to 3:30, 2 to 3:30, working around the class schedule, working around other things. If none of those work, I do stuff by appointment, on Zoom, on Google Meet. All of those are available through that Google Meet link as well, which is also on our Canvas page. There's a whole crap ton of policies in here, most of which are about this relevant to this course. If you're a math major, this is what we do within the math program for this course, and this is where you'll find it within the course with all the different homework projects, quizzes, exams, things we're going to do, and all the different places we're going to do them. I was told there's another COVID surge. I was also told that the university is not doing testing directly. If you get symptoms, stay home. You can watch the recordings I'm making of this, which will be posted to a YouTube channel, which will be linked in our Canvas page after the fact. There won't be a live stream or a live Zoom link because this is running through Big Blue Button in Canvas. But if you're going to be sick, we'll figure it out. We'll make it work. I would like all of you to stay as healthy as possible. Me too. Come to class. Please, it helps. I have anecdata. I don't have enough of a large sample size to really say that I can guarantee you that coming to class helps, but very few people who come to very few classes do really well. It's correlative, but it isn't causal yet. I'm going to give you regular homework assignments for every section we cover. There'll be a selection of problems from each section. From that selection, I'll randomly pick one, grade that one on content, and everything else on completion. There is a complete list of all of the problems for each section. Again, this is a PDF on our Canvas page. So first three sections are going to be due after first question and answer day, and that's a week from Friday. On the Canvas page calendar, all of the assignments are dated. If you copy that to your Google Calendar, I believe that can be done directly. It'll stick the due dates in, and if I change them, you'll have to recopy it. But that'll only happen in a weather or other emergency. We will always have a question and answer day before stuff is due. Again, if you're going to be out for any reason on a day stuff is due, there's a how to scan and email PDFs to me. That's my personal favorite scanning app. It's the one I'm going to use to scan anything I write in class and upload to our Canvas page. One of the modules will say class scans. It'll show you everything I've got. So we're going to do all of it. Why? Because unfortunately, I don't know anybody who can just jack into the matrix and upload this textbook to their brain. I'm working on it, but I haven't gotten there yet. And just like being on a sports team, the only way you get better is to practice. This set of homework is my definition of formative assessment. It's not high stakes, it's fairly low stakes, but it is still the best way to practice what we are doing. Please make sure your turned-in assignments are neat, well-written, legible, etc. If you'd like to learn how to type math, I have a great typesetting program. It's got a learning curve that's almost vertical, so I'm not sure it's worth it. There are 4 scheduled exams. Each one and what it covers is on this schedule in the first module of the Canvas page. So there's our first exam 4 weeks from now. We hit the ground running. It's going to cover all of Chapter 7. If you're going to miss an exam for a known advanced reason, I'll give you the exam in advance. You take it beforehand, go to whatever you're going to, come back, no problem. If you're driving in from wherever you're living off campus and you blow a tire on your way into the exam, take a picture, send me a text message, shoot me an email, call my office phone. It records messages, turns them into email, and emails them to me. I'll give you makeup. If you're like, nope, can't do it, I just don't want to, that's fine. You're allowed to skip one exam during the semester. Your next exam counts double. The problem with that is the grading scale. That grade distribution page right there says that each exam is individually worth about 18% of your grade, which means if you double one, that's 36% of your grade in one 1 hour period. That's a lot of pressure. I don't want to do that. So I would advise against that if at all possible. You will need a graphing calculator. I prefer the TI series. I've used this for now working on almost 30 years. There's a Casio that works very well. There's a Hewlett-Packard that works very well. As long as you do not have a calculator that says on it CAS, which stands for Computer Algebra System, like the TI-89 or the TI Inspires, because they'll do calculus for you, and that kind of defeats the purpose of the class. You will not be able to use your phone, Desmos, Wolfram Alpha, or any other internet-enabled app during the exam. I need a dumb calculator, something that's not connected to the internet. Questions so far? If you hit an 89 in this class, you're guaranteed B+. You might get an A-, I don't know, because curves are not computed until after the final exam is done. Our final exam is, I believe, Wednesday at the ungodly hour of 8 in the morning during finals week. I didn't make the schedule, but I have 2 exams Tuesday and 2 exams Wednesday, and then grades are due Friday for all the seniors and the following Tuesday for everybody else, so that's when I do all the calculation stuff. Class is designed face-to-face, synchronous. You'll get my notes, you'll get all the videos. My goal is to make this hour of class time scaffold, because I can teach it till I'm blue in the face. I can teach it to you, I can't learn it for you. That's a hard difference for me to push out, because putting it in your brain is not a matter of just listening to me. It's a matter of getting it in there, getting it integrated with everything else you already know, and making a coherent story out of all of that. So a lot of times I will do 4 or 5 examples of a particular method, discussing of where it came from, why we use it this way, and in that fashion, then you go out and practice it. And that's where it becomes yours. Big bags, large athletic equipment, etc. Put it against the walls. Try not to impede the aisles. If we have to get out of here, the stairwell is behind you, leading down. Our emergency egress takes us out the front of the building, across the street, on the other side of the big admin circle. So if we get fire alarms or whatever, that's where we go. You'll get starfish messages occasionally. There are 2 starfish surveys in addition to midterm grades, so you'll get feedback from me that way as well. Make sure you can get starfish notifications. Make sure your email address is in there properly. It should have been done automatically, but you never know. If you want to contact me, send me an email. I know it's old-fashioned, right? I do have a Discord. There's a Discord channel for this course if you really want to. You can set up your own however you want to do this. But while we were out during COVID, the Discord channel worked really well if I had to teach from home, because then I would set it up just like this at home, but I wouldn't be able to see your responses because you'll notice there's no view of you all here. This is a one-way camera. But that meant if you wanted to talk to me, you did it over the Discord channel. An option. You don't have to. I tend to try to go to bed at a reasonable hour because I get up at dark 30 and go to the gym before class. So you might not get a response 10:30, 11 o'clock at night. You might not, but you'll get one by 7 in the morning. If you call my phone, it'll automatically turn that voicemail into an email. It'll send it to me. That's fine. I can answer you that way as well. You've got the schedule. You know when we're going to do what. So if you miss something, you know what we did. You miss a day, you know what we did on that day. There are no extra credit assignments. There are bonus problems on some homeworks. They'll be indicated on that sheet. And completion of that ups your grade there. There will be bonus problems on exams, but no additional assignments. Make sure you have a valid email address in Griffin Gate and Canvas. That should have been automatic. You can set up email forwarding if you don't want to use your Seton Hill account, but by default, I send stuff to Seton Hill accounts. I don't remember who countrybutterfly25@yahoo.com is, but that was one of my students. Some of you may grasp the material faster than others. Try to sleep with your eyes open and not snore. If I'm boring you, I promise at some point I will be loud. You'll wake back up. Please set your cellular device to silent or vibrate. If it rings, I'm going to answer it in the middle of class. If it's an emergency, I'm going to give it to you. If it's not, I'm going to hang up on it. A couple of years ago, exactly after I finished that sentence, somebody's phone rang. Texting, messaging, look, I'm asking for 50 minutes. They seem like a long time, but I guarantee you, your friends are busy now too. 90% of classes are scheduled between 10 and 3. It's ridiculous how few classes there are at 8, how few there are after 3, and then the night classes. Everybody wants their classes from like 10 to 3. So almost everybody's in class right now. Please make sure you have your earbuds out, put away. If you've got hearing issues and you need them for something, that should come through Accommodate. So that's from Disability Services. We'll work that out. University is a tobacco-free environment. If you need a smoke, please take it outside after class, at least 25 feet from a door. There are smoking cessation products upstairs in health services, as well as the easy way, just get yourself a nicotine patch or a piece of gum, and you can survive for the time that, if I can't smoke my pipe in class, neither can you. But I haven't smoked in almost 17 years, so. Yeah. Title IX statement, I am a mandatory reporter. If you tell me something, I am required to report it up to our Title IX service coordinator. If you don't let that stop you from telling me anything, but if you want something that is not going to be reported, these are people you can talk to. The Blackburn Center, the Counseling Center, Campus Ministry. You are welcome to refer to the civil rights policy in our policy manual, available through resources on my sheet. This is harassment of any type. We are attempting to get rid of it all, but it means if I see something, I say something. If you tell me something, I'm required to say something. Here's the disability services thing. If you have an issue or a reason for me to give you accommodation, extended test time, additional note takers, a Braille version of a book, an audio boost, whatever it is, it's got to come through their office. They're upstairs, 500 end of this floor, 513 is the room number. And Kim Bassett Cook will help you set up whatever it needs to be dealt with. I'll get a notification. You don't have to tell me why. I just have to have notice. Academic engagement. As I said earlier, I can teach till I'm blue in the face. I can't learn for you. You are an active part of this. I do this most semesters on the first day of class. And if I'm not too busy filling out seating charts, usually I'm standing in front of the room playing the yo-yo. And what people ask me is, how long did it take you to learn how to do this sort of stuff? And I can say with a straight face, I've been carrying the yo-yo for probably 30 years. And I'm an amateur. Because there are people who do this for a living and make money at it, and I'm not one of them. But what I got to learn how to do this was by engaging with it, by taking it with me, by playing while I was waiting for my wife in another store, standing outside waiting to pick up my son from the bus. Whatever it was, I was doing this. Your level of engagement with calculus is going to determine how you do in this course. And I will say with 100% certainty that calculus is less fun than a yo-yo most of the time. But there are places in this course where you're going to hit something that's going to go, what the happened? And that's the point where your tenacity and your desire to engage will be measured. And that's when you come ask me. You come sit in the Math Enrichment Center with me. You sit with one of the tutors. We're going to have a lot of tutors for this course. As soon as I get the information from the Enrichment Center, We'll get Penji, which is the scheduling app for the Enrichment Center. Again, there'll be a link on our Canvas page. And you'll be able to make appointments. You'll be able to drop in and come see me during any of those hours listed earlier. And we'll figure this out. But whether that's me sitting with you and going, well, what did you think of this? Or how did you do that? Or what did you try? It's got to start with, what did you do? Practicing academic honesty. ChatGPT is a wonderful thing. As far as math is concerned, it's almost useless. I asked it to add and it couldn't. I asked it to multiply and it couldn't. On the other hand, Wolfram Alpha is a great site and will do calculus with its eyes closed. As long as you figure out how to format it and write it in, it's great. It does amazing things. It's a good tool once you know the question asked. Copy the homework problem into it, it'll do it. No questions asked. Will you have learned anything? Will you have access to it during the exam? Practicing academic honesty in this course means making your work what I see. That doesn't mean you can't go to Wolfram Alpha after you've done the problem known as this right. Do I have anything close to the right answer? And I've done that on multiple occasions, where I've done a problem and I'm like, I think I got it. Flip open the answer book that came with the textbook. They had something different. Where did I go? And the answers to all the odd problems are in the back of the book. And Chegg is an easy subscription to get you all the answers to all of it, complete solutions. But then you have to go through and figure out where did you do something different to compare it to. If you use an outside source, tell me. I plugged this into my calculator, this is what I got, is a perfectly legitimate thing to say on a problem where I'm expecting you to use your calculator. What questions do you have for me about the way this class is going to go? Okay, the good news is on most days it will be cooler than this. The bad news is today the air conditioner is broken. We got an email about 3 minutes before I came upstairs in the elevator that said the air conditioner will be fixed sometime today. This is Calc 2, which means Calc 1 needs to be in your head, needs to be something you remember for the most part. And we spent an awful lot of time doing derivatives and some basic integrals, and that's the problem. Calc 2 extends all of those ideas. And we're going to spend a lot of time in this course working back through the assumption that you have all of those base derivative rules and all of those basic integral rules in your head. So that means things like elementary antiderivatives. This is the last section that we did in chapter 4 in Calc 1. I said, all right, we know the derivative of something. How do we get the something back? And in a lot of cases, this is simply a matter of remembering how we took a derivative and working backwards. Advantage number 1 is that I can guarantee you there are lots of different functions that have the same derivative. But we did something called the mean value theorem. Which told us about the way in which we compared derivatives. So let's suppose I have two functions. And they're both antiderivatives for the same thing. Okay, the mean value theorem was a long time ago. Count one was a long time ago. How do I remember what the hell this thing said? Derivative is a slope, right? I have two things that have the same slope. Lines. Lines that have the same slope are called parallel. So what I've got is two functions that are parallel. And that means that every point in the entire graph, they're pointed the same way, they're going the same up, the same down, as we go from left to right. That means the space between them can't change. Because if the space between them got narrower, one would be rising, falling faster than the other. But that's change in slope. And we know the slopes are exactly the same. And that means that the original two functions have to be the same distance apart all the time. Another way to say that is to say that one of those differs from the other by this c, whatever c is some number. If it's a zero, then they're exactly the same. My lines then aren't just parallel, they coincide. They're the same line. So if I were to say to you, here's a function that's the derivative of something. What's something whose derivative is 3x squared? Because we did the power rule, right? You bring the power down and you subtract one. So x cubed would become 3x squared. So I could say absolutely an antiderivative would be x cubed. Here's the sneaky part. I just said an antiderivative. Because that c allows me to have lots of other antiderivatives. Because what's the derivative of 5? The derivative of -7 is also a 0. I don't care how ugly the number is, the square root of 117 over e. I don't even know what that number is in slice, but it's a number, so its derivative is 0. Which means I could think of a general antiderivative with a constant to be determined later. And I would write my antiderivative this way. Okay. Each individual problem situation may require a different constant. I'll need more information than just f of x equals 3x squared. To get that constant, I'll need to figure out some other way of nailing it down. More on that later. Here's the downside. I need to remember all of the different ways I took derivatives. Now remember how to do them backwards. In our textbook, in this section, chapter 4, section 9, we have a list. of derivatives we already did. And a bunch of these can then be worked backwards. Page 352, a table of antiderivative formulas. I don't expect you to memorize most of these. In particular, if you took my Calc 1 class, you got a formula sheet with trigonometric derivatives. You had the derivatives, sine, cosine, tangent, secant, cosecant, cotangent, all of those things will be provided to you again. But there were things that were missing from that, some things I did need to remember, like the derivative of a logarithm. What was the derivative of ln of x? 1 over x. So here is a place where we have a relationship between a logarithm and a power. That seems weird. It is, and there'll be a reason for that relationship later on. But that means that the antiderivative of 1 over x is the ln of x. But wait, there's more. Plus c. Now, unfortunately, with the ln of x, there's even more. Oh, here's a technical issue. ln of x only works when x is positive. You put a negative number, the ln of -1, your calculator will barf on that. Or it'll give you some complex number I thing. That's not what we're doing here. But 1 over x works for positive x's and negative x's. The only place 1 over x is broken is at 0. So I would like something that works for an antiderivative in the same places that the derivative existed. And we covered this in the section on logarithms in chapter 3, just barely. It turns out all I need to do is make sure I remember that there's an absolute value there. Why? Because of the chain. When x is negative, the absolute value acts like an extra minus sign. And so I would get the ln of negative x. The derivative would be 1 over negative x. But the chain rule says, hang on, you got to do some extra. And I get an extra negative 1. Wait a minute, negative on top, negative on bottom. Cancel each other out. I get that 1 over x back. So this is actually an extra sneak in there to cover the difference in the domains. One of the interesting things in calculus is that domain pieces, an algebra trick, where is this function actually defined, matter in this place more than they did through most of Calc 1. If I have the derivative of something as e to the x, what was the original? Yeah?
E to the x plus c.
Exactly. The derivative of e to the x is e to the x. Which means the antiderivative of e to the x is e to the x. But wait, there's more, and I got to remember that plus c at that point in time. Here's where I have to start digging back through my memory banks or pull up the book and open it to page 352, where that table was, or find the formula sheet you got from me last year or the last time you took Calc 1, but will be provided to you again later. What's something whose derivative is cosine of x? Tom?
Sine of x plus c.
Exactly. The derivative of sine is cosine. cosine is,
Minus sine of x.
so I have to remember how to deal with that negative. So if I had this, I'd be off by a minus sign. Now here's where I can start saying to myself, I had rules for derivatives where I added things, where I subtracted things, I multiplied by numbers. That's not the right derivative for cosine. The derivative for cosine should be minus sine. So what I say is, okay, if the derivative of cosine is minus sine, then the derivative of minus cosine would be because I get an extra minus sign on the outside, right? And then I get the additional one from taking the derivative of cosine. And that means that this antiderivative is not cosine of x, but negative cosine of x. Even the inverse functions. Unless you have already memorized all of those trig derivative formulas, you'll be looking at this going, that should be like quotient rule or something. No, quotient rule is evil and I don't want to deal with it. So I'm going to try and avoid quotient rule wherever possible. But that actually turns out to come from the inverse tangent. And again, that's one of those, you'll see it a lot. So you're going to end up remembering it, I hope. But it'll be on our formula sheet. You'll often see this inverse tangent written as arctangent because it gives you an angle, and an angle is a measurement of a piece of arc. So how do I generalize? These are all specific cases. We did 3x squared and got x cubed. How do I do it in general? Let me think about the way I did the derivative of something. The power of x. We said this earlier. When I took the x cubed's derivative, what did I do? Take the power out front, that becomes multiplied. Take the new power, reduce it by 1. I want to do all of those things backwards. So let's do it not only each step backwards, let's do the steps in the reverse order. So I took the power down and then I subtracted 1 from the power. To do it in the other order, I need to take the power and add 1 to it, right? So I need to take the power and add 1 to it. But that's not enough, because the other part was I multiplied by the power. Multiplied by the old power, so I want to multiply by the new power. Wait, I don't want to multiply. I want to do it backwards. What's the opposite of multiplying? So I'll divide. Divide by a number 1 higher, and that's my new power as well. Hey, wait a minute. One more thing. You'll also often see this written as separate pieces. I don't care if you make it 1 fraction of 2, but this is my power rule backwards. But now that means I can do any power except 1. What's the only power that's going to that up? -1. Because if n is -1, then I have 1 over 0. You divide by 0, the universe explodes. Don't do that. It's a bad thing. So I need to remember in here, this only works when n is not -1. Well, that's an exception, right? Wait a minute. Wait a second. What is x raised to the -1 power also written as?
1 divided by x.
Which we already figured out the derivative of and the antiderivative of. We know what to do in the exception because we already did it. Oh, you sneaky little. It works. But that means I can put all of this together. And I can do combined functions with different pieces and different things in them. And again, sticking with the derivative rules I knew from before. I've got things added and subtracted here, right? You're adding and subtracting. What did you do for taking derivatives? X squared plus 3x. I want the derivative. What do you do? Separate. So I'll do the derivative of the sine x part separately from the derivative of the other stuff. Wait, there's more. In that fraction, I said I didn't want to do division. Division sucks. I noticed that the denominator of that fraction is one thing. Top is multiple things. So I'll separate those as well by treating each one of them as a separate fraction. And when I do that, I find that I can do a little bit of the algebra to rewrite. Because again, I don't like dealing with division. So what do I do with that first piece? The 2x to the 5th over x. Technically, it's the second piece, first part of my fraction.
It would be like 2x to the 4th. Subtract away the exponent.
Exactly.
1.
2x to the 4th. And then I can do the same thing in the second fraction, but I have to convert the root to a fraction. And remember, root x is a 1/2 power. Which means I have a 1/2 on top and a 1 on the bottom. Subtract, I get a -1/2. And now I can do my antiderivatives. That's why there's a change of equal signs there, because this is still f prime. This is f. But that means now I say, oh, let's figure out f. Something whose derivative is sine.
Minus 4 thirds sine x.
The 4 stays there because it's a constant. Constants stay in front of their functions. And now for these two, I'm going to use the power rule. The 2 stays there because it's a constant. And now I do the deal with x to the 4th. The minus stays there. If I'm adding two things, I do each one separately. If I'm subtracting two things, I do each one separately, but I leave the sign in the middle. I add 1 to my power. My power becomes a positive 1/2. And then I divide by that new power. And now, last but by no means least, I did 3 antiderivatives. Shouldn't I have constant 1 and constant 2 and constant 3? Those are 3 different numbers. Just glom them all together and stick them on at the end and call it one big constant. as long as I remember that it's got to go in the line immediately after I do my antiderivative parts. I can't wait until the very end and then throw it in. I got to do it as soon as I do the antiderivative. The following steps are optional. I would simplify algebraically. I have a fraction within a fraction. I don't like that. I have a product of two numbers that right now look like a mixed numeral. 2 and 1/5 is not a mathematician's sentence ever. I know that makes sense out there in the real world, but that should be multiplied, right? Not added. And when I write it like that, it looks like addition. So I'm going to go through and I'm going to make a couple of simplifications. A fraction over fraction, take it out, flip it over. A 1/2 power is a square root. And that is the answer I'm more likely to see in the back of the book, more likely to see on an answer key, and more likely to see if I throw this into a computer. My first calculus teacher, Maria Soto, this tall, woman was shaped like a barrel. I had her at 7:30 in the morning. Maria Soto was from the University of Havana. I grew up in Miami. And at 7:30 in the morning, I got a lot of calculus. If I had lifted the plus C off the first line and only put on the second line, I lost a point. If I did more algebra in separate steps, I lost a point each time I forgot to write it down. I got a homework back with a negative score once. I'll never forget that plus C. Thank you, Maria Soto. Questions? I didn't know, I still, right now, have no idea what that C should be. It's some constant. It could be 0, it could be 100, it could be negative 32. I have no way of knowing unless I'm given additional information about the problem. Any problem like that involving derivatives is called a differential equation. We'll look at more differential equations in chapter 9, but at the very least, if I gave you extra information about F, then you'd be able to figure out what this value of C was. So here, I've given you the derivative, and I've given you this information. This is called either an initial condition or a boundary condition. There's a slight technical difference between the two, but it's not something worth covering here. So what do I do to incorporate that extra information? I do my antiderivative exactly the way I did above. And then at the very end, I say, oh, I've got this C. Let's plug in our X, plug in our output, and evaluate what C should be. Let's do this one. The problem with this piece is not the additional information. It's that. That's disgusting. I know what to do with this. What's the antiderivative of e to the x? What the do I do with this?
I was thinking you could like back up this one and be right as like 1 over x squared plus 1, take it through that.
Oh,
Easy side.
hold that thought. I have not done my antiderivative yet, so that's still an equal sign. That's still f prime. That is, only in the previous one I wrote it 1 over 1 plus x squared. 1 plus x squared plus 1 doesn't matter. This is something I know the antiderivative of. Oh, thank God. So I do get f of x, the antiderivative of e to the x, and then my inverse tangent. And then my big plus c. Maddie, that's the pattern recognition part of this. That's where I have to go, okay, I've seen this before. What do I remember? And that's where practicing comes into play. The more often I'm exposed to these problems, the more the algebra will become a triviality and not something that's going to trick me up and beat me over the head. So, how do I get here? Okay, put in this x everywhere you see it, and set the whole result equal to -2. E to the 0. E to the 0 is 1. Anything raised to 0 power except 0 itself is 1. Tangent inverse of 0. Your calculator has an inverse tangent button on it. You should be using it at this point in time. Or you should have the table for the basic angles with the exact values. 0, 30 degrees, 60 degrees, 45 degrees, 90 degrees, sine, cosine, and tangent. Those base values need to be up here in your head. Or you have to know what decimals you're going to get and what exact values they correspond to. Fortunately for us, what's the inverse tangent of 0? Which means c is -3. And that means that I now have a complete formula for my particular f of x. So when we did our antiderivative and got that equation with the arrow there, e to the x plus 20 tangent inverse of x plus c, that's a general antiderivative. And it basically describes a whole family of parallel curves. But now we've nailed down one of them. And said this one goes through the spot 0, -2. Particular solution to our differential equation. If I had a second derivative, I could do this twice. There's an example in the text about throwing a ball off the edge of a cliff. 432 feet in the air, and you go, whee, when it hit the ground. You know how high you are. You know how fast the ball is going up when you release it. When it hit the ground. Well, that's a position equation. If I had velocity, I could take an antiderivative and get position. I only have a constant for velocity. I know how much it is when I let it go, but there's a force acting on an object I throw in the air. What force? Gravity. That's an acceleration. So I have to go from acceleration to velocity, from velocity to position. I have a second derivative, and I finish after doing two sets of antiderivatives with a position equation. Not only can I tell you when it hits the ground, I can tell you how fast it's moving when it hits the ground. Because I know the velocity now at any point in time, having gotten that as an intermediate step. Almost all of the physics rules we do are derived from these ideas, working our set backwards. On our Canvas page is already posted the key to the assigned homework I gave in Calc 1 for this section. So if you want to see a bunch of these, give them a try. It's listed on our homework assignment page, but you're not going to turn it in. It's already up there for you to look at. But that means I'm going to start looking at other rules that we did. I did addition, I did subtraction, I did constant multiplication. I've got the chain rule, I've got the product rule, the quotient rule, I got a whole bunch of other rules. So we're going to go through them, in my opinion, from easiest to hardest. And look at other algebraic techniques that will allow us to do integrals in easier ways. And that is the entirety of this first chapter. Working the rules we did I hope you all have a wonderful rest of your day. I will see you on Wednesday.